Algebra 1 EOC Review Part 5 Exponents, Radicals, Monomials, Polynomials, and Factoring. Alright, as you can see in this review, I'm going to cover a lot of things. Okay, now before we start, I just want to say at the beginning, I'm going to go as quickly as I can and cover basics about the radical sign, exponents, basic things that you know but may have forgotten. Okay? But what I want to emphasize is that the end of the video is where the important stuff is, towards the end of the video or towards the end of this lesson. When I go over factoring, that's really important. But the thing is, in order to go over that, I got to make sure you remember all the basic information that you need to know about all this other stuff, okay? All right, so first of all, when you have an exponent that's a fraction, all right, you would rewrite it this way. Okay, so notice where A and B is. Just imagine that you're tilting it to the right side. If you tilt that fraction to the right, the A would fall over here and the B would fall over here. Okay, now that's the first part. So if I rewrite this fraction, let me say that better. If I rewrite this exponent with a radical sign, it would be this. That's how you rewrite it. That's number one, okay? Así que cuando tienen una fracción en el exponente se escribe de esta manera. Imagínense que lo están poniendo de lado para la derecha. Okay, now there's two different ways to work this out. An easy way and a hard way. Alright? The hard way, the difficult way, the difficult way would be to try to do the 27 to the second power, which will give you a big number, and then whatever you get to get the cube root of that number. Obviously, you would use a calculator, but if you do it the easier way, you could do most of these without a calculator. The easier way would be like this. The easier way would be to do this first. I'm going to put parentheses. To do this part first, and then this part second. So just imagine that you're putting parentheses around this part and doing this first. You get the same answer. So what's the cube root of 27? The cube root of 27 is 3 because 3 to the third power is 27. 3 times 3 times 3 is 27. And then I just do 3 squared and my answer is 9. Alright, so the quick way is to do this part first. On your calculator, remember that, hold on, where is it? For the sake of time, I'm just going to point out this key allows you to put in whatever root you want to find, whether it's the square root, the cube root, the fourth root, the fifth root, whatever. And this key allows you to put whatever exponent you want. Alright? Alright. I'm doing this review fast, so if you don't get it, I'm sorry, but I can't spend an hour explaining that, alright? So this one, 27 to the oh, my bad. So this one is asking you to get the cube root of 27. When it's a 1 here, you don't write it. The cube root of 27 is 3, because 3 to the third power is 27. This is asking you to get the square root of 49. Remember, when there's a 1 here, you don't write it. And when there's a 2 here, you don't write it either. I just wrote it anyways. But the square root of 49 is 7. This is asking you to get the cube root of 8. The cube root means what number to the 8th power equals 8? That would be 2, because 2 to the third power equals 8. 2 times 2 times 2 gives you 8. Alright? Remember, I know you're not going to have an iPhone on the exam, but you are going to have these keys. These buttons are on the exam. If you just need the square root, you could use this button. If you need the cube root, you could use this button. And if you need any other root, you would hit this button. Just like up here, if you need the square number, you hit this button. Cube a number, you use this button. Cube means to the third power. And any other exponent, you would use this button. Alright, so right here, 1 to the 1/2 square root. That means just get the square root of 1, which is 1. Right here, get the square root. Again, I keep writing the 2, but you don't write the 2. When it's a 2, you don't write it there. The square root of 16 is 4. Okay, look at this one. This is a more interesting one. Let me erase everything. Alright, this would be get the fourth root of 16 to the 7th power. So the quick way would be do this part first. The fourth root of 16 is 2, because 2 to the fourth power is 16. Alright, and then you do 2 to the 7th power. In your calculator, you would put 2, then you hit this button, then you hit 7, and then you hit equals 2. And Let me get my calculator. Sorry, let me log into my phone. Alright, so 2 to the 7th power, which will give you 128. Alright, and then this one right here, you got to get the cube root of negative 27. That would be negative 3. Again, this is just a quick review. I don't have time to go too deep into this. If you don't know, if there's something that you feel that I'm going too fast, you could always Google this, alright? So keep that in mind, alright? You have the internet. You have everything, all the information in the world at your fingertips. You got to do your part too. Alright, now let's talk about negative exponents. You're never supposed to leave a negative exponent in your answer. Okay, you're always supposed to get rid of the negative sign in the exponent. And the way you get rid of it is by putting this is called the base, alright? Putting the base and the exponent in the opposite location. So like if it's in the numerator, you put it in the denominator and that gets rid of the negative sign. So right here I got 2 to the negative 4th power. I just put it in the denominator and I put a 1 on the top and that gets rid of the negative sign. Alright, here I got several examples. Let's look at this one right here. Let's look at this example right here. Alright, it has 2 over 5 and the entire thing to the negative 6th power. Okay, you should think about it as this way. 2 to the negative 6th power over 5 to the negative 6th power. In both cases, I got to get rid of that negative sign. So I would put 2 to the negative 6th power in the denominator, and that gets rid of the negative sign, and 5 to the negative 6th power in the numerator, and that gets rid of the negative sign. And then you would work that out. You always got to simplify. But the point is, if the negative exponent is in the numerator, you got to put it in the denominator to get rid of it. If the negative exponent is in the denominator, you got to put it in the numerator to get rid of the negative sign. You always put it in the reciprocal location. Alright? Así que si una respuesta final nunca debe contener un exponente negativo. Para quitar el exponente negativo se pone, si está el número en el numerador, se pone en el denominador y eso le quita el signo negativo. Y si está en el denominador, lo tengo que poner en el numerador y eso quita el exponente negativo. Alright, so which of these is equal to 37 to the negative 6th power? Just put it in the numerator and that's your answer. Which is equal to 93 to the negative 7 power? Just put it in the, by the way, did I say, I hope I said it correctly. Put it in the denominator and that's your answer. I can't remember what I said. I think I might have misspoke. Alright, so on this one, which is equal to 93 to the negative 7 power, I would just put that number in the denominator, and there's your answer. Here, which is equal to 62 to the negative 2 power, and over here, which is equal to 2 to the negative 59 power. Alright, that should be easy. Oh, wait, I made a mistake here. You got to be careful when you're going fast because that one still had the negative sign. When I put it on the bottom, that gets rid of the negative sign. So this is easy, but you got to look carefully because it's also super easy to make a mistake, especially when you're trying to go fast. Alright, so write your answer as a fraction or a whole number without exponents. Evaluate usually means simplify. Get the final answer. So this, I would do that. And 3 to the 4th power would be... I believe it's 81. Let me make sure. Yeah, 3 to the... Yeah, so this would be 1 over 81. This one would be 1/2. That one's easy. This would be 1 over 4. This one would be 1 over 64. And this would be 81 times 9. 1 over 729. All of those are easy. There should be no issues with those. Just a quick review. Alright, now when you multiply two terms with the same base, you could add the exponents. So here I'm multiplying. The base is the big number, right? So if they got the same base, you add the exponents. So the answer would be you add the 2 plus the 3, it's 2 to the 5th power. And of course, you may have to work that out, right? But this is the rule. When you're multiplying and you have the same base, you add the exponents. Cuando están multiplicando y la base son igual, se suma los exponentes. All right, so right here, this is fast. This would be t to the 8th power, m to the 4th power, p to the 10th power, v to the 9th power, u to the 10th power, q to the 9th power. That's it. What was that, 10 seconds? Moving on. All right, now when we divide, you subtract exponents. All right, so here's my problem. You subtract 5 minus 2, and you get w to the 3rd power. Why does that work? Because if I spell it out, w to the 5th power over w to the 2nd power, these cancel out, and you're left with w to the 3rd power. That's an easy example. So again, here's the rule. When you're dividing and you have the same base, you subtract the exponents. Cuando están dividiendo y tienen la misma base, se resta los exponentes. Now look at this example over here. Notice that the exponents have, there's more than one way to think about this one, all right? But notice that the exponents have negative signs. So one way you could do it is first get rid of the negative signs by putting this one up here and this one down here. And now you got to subtract. So when you subtract, okay, again, there's two ways to think about it. First of all, on the top, w to the 2nd power means w times w. On the bottom, w to the 3rd power means w times w times w. These cancel out, and you're left with that. Normally, this would be your answer, or you could also write it like this, depending on the question. All right, you could write it either way depending on what they're asking you. All right, but you should understand both. All right, I could have also just done 2 minus 3 is negative 1. So again, when the base is the same, you subtract the exponents. Moving on. All right, so right here, let me do an easy one first so that let me do this one first because it's easy. All right, you subtract the exponents, so the answer would be k to the 2nd power. That one's easy. Over here, you subtract the exponents, and your answer would be f to the negative 5th power. Or you could either write it like that. Oh, my bad. Hold on. It says express your answer using positive exponents. So it gives me f to the negative 5 power, which you would write it like this, 1 over f to the 5th power. That would be your answer. All right, so like this one, I subtract the exponents. So look, if I subtract the exponents, negative 4 minus negative 7, that's going to become negative 4 plus 7. Negative 4 plus 7 is positive 3. So my answer is w to the 3rd power. Another way you could have thought about it is first get rid of the negative signs. So w to the negative 4 power over w to the negative 7 power becomes w to the 7th power over w to the 4th power. And when you subtract the exponents, you get w to the 3rd power. All right, whatever works for you, all right? As long as you get the right answer. And then this one over here, one way you could think about it is first get rid of the negative exponents. So you'd have 1 over q to the 5th power times q to the 6th power, which would equal 1 over q to the 11th power. That's one way you could think about it. Another way you could think about it is negative 6. If you subtract the exponents, negative 6 minus 5 equals negative 11. So you would have, q to the negative 11 power, which would equal 1 over q to the 11th. Either way, the answer is 1 over q to the 11th. Moving on. Okay, last rule for exponents. It's called the power rule. Basically, when you have an exponent raised to the power of another exponent, you multiply the exponents. All right, so here's my problem, and here's my answer. If you want to skip the explanation, I multiplied 2 times 3, which gives me 6. Cuando tengo un exponente, al poder de otro exponente, se multiplican los dos exponentes. Así que se multiplica en este caso 2 por 3 y me da 6. Why? Because look, if you ignore this a second, it's saying whatever's inside the parentheses to the 3rd power. So I'm multiplying whatever's inside the parentheses 3 times itself. And what's inside the parentheses is x squared. And if I break it down further, x squared means x times this. Well, you know what? Let me do it like this. This means this times this one times this one. So if you count how many x's there are there, you end up having what it says right here. So that's why mathematically it works. You multiply the exponents. Moving on. All right, so a quick couple of examples. Here I got an exponent raised to the power of another exponent. So you multiply the two exponents. So you're going to have x to the 18 over 4 power. You always got to simplify fractions. So when I divide that by 2, I'm going to get x to the 9 over 2 power. All right, and that would be, wait, x to the 9 over 2. That 2 didn't come out good. So that would be my answer in this case. That's all they want me to do. The point is you multiply the exponents. One more example. Oh, no, this one I got to do more. Okay, so look. I got 27 y to the 2nd power and the whole thing y to the third power. You could think about it as that you got to distribute this exponent to everything that's inside the parentheses. Alright? Tengo que distribuir este exponente a todo lo que está dentro de los paréntesis. So this will be 27 to the 1/3 power times y. The y already has an exponent, so I got to multiply those two exponents. Y ya tiene un exponente, así que tengo que multiplicar ese exponente con este exponente. Now this means get the cube root of 27, and the cube root of 27 is 3. So my answer would be 3y to the 2/3 power, because I can't simplify this any further. Guys, I realize I'm going fast, but there's a lot to cover. Again, you could Google any of this if you feel that you need to check more out on it. And by the way, I'm getting this. I have a Algebra 1 intensive math class of freshmen. And up here, I didn't have time to get rid of this. But this tells you IXLs that practice that. And a lot of you guys have access to IXL. Nobody's stopping you from going on to IXL and practicing a few problems in any of these topics. That would be actually a very smart thing to do. Okay, so now let's get to monomials. A monomial is a number, a variable, or a product of numbers and variables. Monomials cannot include addition or subtraction. A monomial is basically this. That's a monomial. This is a monomial. That's a monomial. It's basically a number or a variable or numbers and variables together that aren't separated by addition, subtraction, multiplication, or well, my bad, not multiplication, but that aren't separated by addition or subtraction, my bad. All right, so I'll say it again. A monomial is either a number, a variable, or a product of numbers and variables that do not include any addition or subtraction. All right. Un monomio es un número o un variable o un producto de números y variables que no incluye sumar ni restar. Okay. And polynomials are when you have several monomials together, separated by addition or subtraction. Okay. Polinomios son cuando tiene varios monomios juntos, separados por sumar y restar. All right, so like just real quick to talk about monomials, this is a monomial, this is a monomial, this is a monomial, 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 monomial. Try saying that fast. All right, so look, I'm not going to spend a lot of time on this. To add and subtract polynomials, all you're doing is combining like terms, but the only thing that you got to watch out for, first of all, let's look at the addition ones because those are cake. Those are so easy. All right, all you do is add combine like terms. So 7d squared plus 5d squared is 12d squared. There's only one 5d, so that stays by itself. And there's only one number with no variable, so that stays by itself. That's easy. All right, same thing with this one. The only thing you got to watch out for is when you subtract, you always got to distribute this negative sign to everything here. And that's what you're most likely, a lot of you guys, to make a mistake with. All right, so when you subtract polynomials, you got to distribute that minus sign. So the problem is actually 7w squared plus 5w plus 5 minus 4w. This is the part you're most likely to screw up. Minus 1, not plus 1, minus 1. Because you got to distribute the negative sign here, and that negative with this positive creates a negative. And now you just combine like terms. All right? I'm not going to go over that a lot. You could look at these problems and practice them on your own if you want to be sure you understand, okay? Lo único que tienen que tener cuidado cuando están sumando y restando polinomios es cuando restan, siempre tienen que distribuir este signo negativo, y eso es algo que es muy fácil para estudiantes olvidarse de eso y no hacerlo correctamente y cogerlo mal. Por ejemplo, aquí cuando distribuyo el signo negativo, este problema es menos 4w menos 1. Y muchos de ustedes se les olvidaría escribir menos 1 y en lugar de escribir más 1 y cogerlo todo mal. Eso es lo que tienen que tener cuidado. Alright, those are examples with the answers. The answers are in the blue box. Courtesy of yours truly. Okay? Ahí está la respuesta. If you want to practice them, you can practice them and make sure you get the same answer I get. Write the problem on a piece of paper and you work them out and see if you get the same answer. Alright, so I guess I forgot to put the answers on those. Sorry about that. Alright, when you multiply, this everybody should know. I'm not going to waste time on this. You just distribute. Alright, distribute. Tienen que distribuir. Again, you could check it out and try it on your own if you want to make sure that you get the same answer I get. Okay, let's talk about this. Alright, this, I don't know. I think this is so easy, but I don't know why. It seems like in math books, people make a big deal out of this. To me, it's like common sense. All right, when you're multiplying two binomials, you may have seen this in the past. I don't even like teaching it with this. So personally, I don't even say that. All right, I'll talk about it in a second, but just in case, if that rings a bell, this is what this is, all right? When you're multiplying two binomials, bi means two. So that means that you have two terms in this parentheses and two terms in this parentheses. All right, what you got to do is when you take the first term and distribute it to each one of these, so x times 4x is 4x to the second power. X times negative 4 is negative 4x. Now do the same thing with the second term. Distribute it to each one of these. All right, 3 times 4x is positive 12x. And 3 times negative 4 is negative 12. Now I combine like terms, which means I'm going to simplify this part right here. Negative 4x plus 12x is positive 8x. So my final answer is 4x squared plus 8x minus 12. That's not difficult at all. All right, again, each one of these, you got to multiply the first term times each of these, and then the second term times each of these, and then finally combine like terms and simplify. I'm not going to spend a lot of time on it. You could do it yourself and practice it. The FOIL thing stands for the FOIL method. It stands for first, outer, inner, last. So I multiply the first terms, then I multiply the outer terms, then I multiply the inner terms, and then I multiply the last terms. If that helps you out, congratulations. Use it. I don't bother with that FOIL thing. To me, it's just common sense. All right. Así que cuando tienen que multiplicar dos binomios, simplemente tienen que primero multiplicar el primer término por cada uno de estos términos y después el segundo término por cada uno de estos y al final simplificar la respuesta y combinar términos iguales. Es bien fácil. Pueden practicar esto para ver si cogen la misma respuesta que yo tengo, si quieren practicar y estar seguro que lo entendieron. All right, here's some more examples. I'm not going to waste time going over them. You could practice them on your own. What is this? Okay. All right, this is very important. Now we're into the factoring part. All right, this is the part where definitely you need to look at it, right? All right, so look, factoring is basically, the way I like to explain it is that factoring is the distributive property backwards. The distributive property backwards. All right, so like if you look at my answer, if I were to do the distributive property, I would get the question in this case, all right? So what I'm doing is in each one of these, I'm factoring out the greatest common factor of the numbers and of the variables. This is something that is very important because we're going to use it in this lesson and in my next lesson, which I'm telling you right now, section 2 of the Algebra 1 EOC has a ton of stuff that you got to know your stuff. All right, look at part 6 of my review so that you can see what's on there, but that involves factoring. And listen, you're going to have a calculator, and guess what? If you don't know what you're doing, your little calculator is going to be useless to you in section 2 if you don't know what the heck you're doing. All right, so I'm telling you right now, don't think that because you're going to have a calculator that part's going to be easy. That part is going to be the toughest one. That's why they're like, here's a calculator. Good luck. All right, so you definitely better know how to factor, especially before you look at part 6 because you need it in part 6. All right, so I hope that scared you enough. All right, so look, first let's look at the numbers. What's the greatest common factor of 3 and 6? 3. Factors are the numbers that you multiply to get 3 and 6. So, by the way, a factor cannot, like a greatest common factor, cannot be bigger than one of these numbers. All right, so my greatest common factor cannot be 6 because that's bigger than 3. All right, and for the y's, the greatest common factor is y. And now just ask yourself, 3y times what will give you 3y to the third power? 3y times y to the second power. 3y times what? My bad. 3y times what will give you negative 6y? 3y times negative 2. That's how I get my answer. Listen, I realize this is something that we could spend a whole class practicing. You need to practice this on your own. Look at all the examples I put. You could easily just write down the question and see, ignore my answer and see do you get the same answer that I got. Look at how they get pretty involved. Although it's all basically the same thing. It's honestly not difficult. You just need to practice a few. But if you just look at this and be like, oh yeah, I got it, you're going to be surprised that you don't, it's very possible you don't really understand it. All right, so like look at these. First I check the number. The greatest common factor of 14 and 28 is 14. Put oh, my bad. Hold on. The greatest common factor of 14 and 28 is 14. And the greatest common factor of t to the 5th power and t to the 4th power is t to the 4th power. when we're dealing with the variables with exponents, you're just getting the variable with the biggest exponent and putting it on the outside. Once you work out a few, you'll understand why. It's the kind of thing where I could explain it, but until you do it, you're not really gonna get it. All right. Now look, 14 t to the fourth power times what will equal 14 t to the fifth power. I need one more t, because when I multiply these, remember, you add the exponents. T to the fourth power times t to the first power is t to the fifth power. Okay, now 14 times what will give you negative 28. 14 times negative 2. And t to the fourth power times what will equal t to the fourth power times 1. So for that one, I don't need to put anything. All right. Over here, you know what? I'm just gonna leave these displayed. You guys need to look at it, and again, it's like the type of thing that you really need to do it. And of course, you need to know your timetables. If you're very weak in your knowledge of timetables, that's your issue right there. Okay. Because when you look at this, if you don't know your timetables, you're going to look at this and be lost. All right, this is just going to be randomness to you. But hey, you're in high school and you still don't know your timetable, so whose fault is that? It's not your teacher's fault. It's not your parents' fault. By this stage of the game, if you still don't know your timetables, it's your fault. Stop watching so much TV or Netflix or being on social media and learn your timetables already. If a first grader and second graders can do it, why can't you? What does that say about you? All right, rant over. All right, guys, so look at these. Again, this is super important. For the sake of time, I'm going to move on. You got to practice this to make sure you understand it. There are, by the way, all these examples, I got them from IXL. Most of you have IXL accounts. All right, go onto IXL and search up factoring out the greatest common factor. All right, and you could practice these. Or again, you don't even have to use IXL. You could just write down my questions, write them all down, and go off to the side, close your computer, and just work them all out and see if you get the same answers I got. But if you don't practice this is very important, right? Deben practicar esto, escriben los problemas, háganlo en una hoja sin mirar mi respuesta y miren si cogieron la misma respuesta que yo cogí. Pero esto es básicamente la propiedad distributiva al revés. Okay? All right. Okay, now look, this is when you have the difference, factoring the difference of perfect squares. Again, on the review after this, you need to know this already. And section 2 of your exam is going to have a lot of this stuff, and it's not difficult. So first of all, look at what that says, the difference. The difference means subtraction. So if you look, all of these examples, we're subtracting in every single example. And perfect squares are numbers that you could get the square root of, and that let me say that better. Perfect squares are numbers that when you get the square root of them, you get a whole number. Like so for example, 16 is a perfect square, 25, 36, 49, 64, 81. Those are all perfect squares. Again, but to do this, you need to know your timetables. So if you look at this, the square root of 121 is 11. The square root of x squared is x, and the square root of 144 is 12. So look, whenever you have the difference of perfect squares, you just put 2 parentheses. In one of them, you're going to make it plus, and the other one, you're going to make it minus. And then you're just writing the square root of this one here, and the square root of this one here and here. All right, let's look at another one. So I'll say it again. I have the difference of perfect squares. I'm subtracting. And this is a perfect square because the square root is 3. And this is a perfect square because the square root is x. So I'm just writing 3 in the front, x in the back, and make one of them plus and one of them minus. That's it. If I multiply this, you'll see that you get the same answer once you simplify. All right, again, the difference of perfect squares. I'm subtracting, and I got a perfect square in the front and in the back. The square root of 4 is 2, so I write a 2 here and a 2 here. The square root of x squared is x, so I write an x here and an x here. And make one of them plus and another one minus, and that's your answer. I have more examples on the next slide. Let me just say that in Spanish. Okay, así que estamos factorizando la diferencia de cuadrados perfectos. Cuadrados perfectos son números como 16, 25, 36, 49, 64. Números que cuando le coges la raíz cuadrada te da un número entero. Ok, así que la diferencia quiere decir que esto es cuando estamos todas estas situaciones estamos restando. Eso es lo que quiere decir la diferencia. Y en cada uno de estos problemas tengo un cuadrado perfecto en los dos lados. La raíz cuadrada de 121 es 11 y la de x a la 2 sería x. Así que escribo 11x adelante en los dos paréntesis y la raíz cuadrada de 144 es 12, que lo escribo aquí. Y hago uno sumar y el otro restar y ahí está mi respuesta. Si yo multiplico esto, te va a dar, cuando lo simplifica, te da lo que estaba aquí originalmente. Ok, así que miren los ejemplos y practíquenlo. Alright, here's some more examples of the difference, factoring the difference of perfect squares. Here's an easy one. If you're struggling to understand it, I don't know why I put it twice, but if you're struggling to understand this, alright, I got the difference of perfect squares. So I make two parentheses, I make one of them plus, the other one minus, and I put the square root of x squared in the front, which is x, and the square root of 49 in the back, which is 7. And that's it, I'm done. It's not that difficult. Ok, así que si no lo están entendiendo muy bien, aquí tengo la diferencia de cuadrados perfecto. Ok, así que pongo dos paréntesis, uno lo pongo sumar y el otro restar, y pongo la raíz cuadrada de x a la 2 al frente, que sería x, y la raíz cuadrada de 49, que es 7, en la parte de atrás, y ya. Alright. Those are more examples. They get a little bit more complicated, but it's the same basic concept. Again, you should look at them and try them out yourself. Okay, now, this you haven't done since last year, and it's very important again. I keep saying it, but I'm saying factoring is very important for the next lesson and for the whole section 2 of your exam. Alright, so factoring when the leading coefficient is 1. What I mean is, here I got a quadratic expression, alright, and the leading coefficient is an invisible 1. The leading coefficient is 1. So the method I'm going to go over only works when the leading coefficient is 1. The coefficient that's in front of the variable with the exponent that says 2. Alright, lo que le voy a explicar solamente trabaja cuando estamos factorizando una expresión cuadrática donde el coeficiente al principio es el 1 invisible. Esto solamente trabaja para estos problemas. Alright, so what you're going to do is this. And the answers are there, but let me go through the process. Alright, you make two parentheses. I put the square root of this in the front, which is m. Okay, now here's the important part. Right here, you got to put two numbers that when you multiply them, will equal this number, but when you add them, they gotta equal the number in the middle. I'll say it again. Two numbers that when you multiply them equal this number, but when you add them, they give you the number in the middle. So look at my answer. Positive 7 times positive 1. When I multiply that, that equals 7. When I add it, it equals 8. Okay? Así que tengo que poner dos paréntesis. Al principio pongo la raíz cuadrada de lo que esté aquí, que en este caso es m. Ahora aquí tengo que poner dos números que cuando se multiplican te da el número que está aquí y cuando se suman te tiene que dar el número que está en el medio. Así que aquí está mi respuesta, 7 y 1. Cuando multiplico 7 por 1 me da 7. Cuando sumo 7 más 1 me da 8. Alright, so here same thing. 23 times 1, they're not all this easy. 23 times 1 is 23 and 23 plus 1 is 24. Alright, these are all pretty, okay, look at this one. 2 times 11 is 22. 2 plus 11 is 13. Again, you got to practice this. If you just look at me doing it, you're going to be like, oh yeah, I got it. And then when you get to the test, you're going to be like, oh wait, I don't really understand this. I got this from IXL. Alright, over here, 7 times negative 1 is negative 7. 7 minus 1 is positive 6. Over here, 10 times 2 is 20. 10 plus 2 is 12. And by the way, like when you go to do this, alright, let me walk you through the process a second. Let's say I want to go to do this. Let me pick the wrong numbers a second, okay? Déjame coger números que son equivocados para que vean algo, okay? If I try to do this with like, let me see, what do you multiply to get 20? Could it be 5 times 4? Like you gotta do trial and error. The better you know your timetables, the better you'll be able to pick the numbers right off the bat. But if you pick 5 and 4, yeah, you multiply them and you get positive 20. But when you add 5 plus 4, it does not give you 12. So that tells you, oh wait, this is wrong. Let me try a different set of factors. Alright? And what you could do is this. You could write, okay, what numbers give me 20? What numbers can I multiply to get 20? I can multiply 1 times 20 2 times 10, and 4 times 5. So check those combinations. When you add them, which one of them will give you 12? It's got to be this combination right here. Okay? Aquí tengo escrito los factores de 20. Todos estos números cuando se multiplican te da 20, pero solamente esta par cuando se suman te da 12. All right, let me try the same thing over here. No, not this one. Let me go to the next slide to get a different example. Hold on. Let me look for a good example here. All right, let's look at this one right here. All right, vamos a mirar este ejemplo. All right, so the factors of 30, look how I'm writing them. And obviously, you can only do this if you know your timetables. But starting with the number 1, I can multiply 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Those are all the numbers that you could multiply to get 30. Esos son todos los números que se multiplican para coger 30. Now I can see, okay, what combination of that can give me 17? Not 1 and 30, not 3 and 10, not 5 and 6, but 2 and 15. When you add them, they give you 17. So that has to be it, okay? Esta es la única combinación que cuando se suma te da 17. All right, let's try this one over here. Miren a este. All right, so let's say, I mean, the answer is there, but let's say I didn't know the answer. All right, so I'm going to write the factors of 40. 1 times 40. 2 times 20. 3, no. 4 times 10. 5 times 8. Let me think, make sure I'm not missing any. Okay, no, that's it, right? So those are the factors of 40. Okay, now from that combination, I got to see from those combinations, I got to see which pair could I add or subtract to get 3. 1 and 40, no. 2 and 20, no. 4 and 10, no. 8 and 5, yeah. If you subtract 8 minus 5, you get 3. And this is negative 40, so that means I got to play with the plus and the minus to see which combination, when I multiply it, will give me negative 40, but when I add them, will equal positive 3. Again, you need to do it to fully get it, especially if you haven't done it in a year. You may kind of get it, but you got to actually work it out so that you could really get good at it. You need to practice it. Okay, tienen que practicarlo para estar seguro que lo entienden. Si solamente me miran, no lo van a entender bien. All right, moving on. Okay, now look. Now factoring when the leading coefficient is not 1. So look, in these examples, the leading coefficient is not 1. Okay, así que aquí factorizando cuando el coeficiente al principio no es 1. All right, so look, these you got to do trial and error. Okay, tienen que tratar diferentes combinaciones. So first of all, 3k to the second power, there's really only one combination that you could use here, which is that. Okay, now I'm gonna try putting here the numbers that I can multiply to get 7 to see which combination works. Let me show you what I mean, all right? 7 times 1 gives you 7. But now I'm gonna actually multiply all of this to see if I get what was my original expression. Because I gotta check if this is right, because it could be, some of these are wrong when you try them at first. Tengo que chequear si esto está bien, no estoy seguro. Así que lo voy a multiplicar. So, again, to multiply this, you do the first term times each of these, and then the second term times each of these. Okay, so 3k times k is 3k squared. 3k times 1 is 3k. 7 times k is 7k. And 7 times 1 is 7. Okay, when I look at this tells me that this is wrong. Because when I simplify this and add this, I don't get the same thing. I get a wrong answer. Cuando simplifico esto, no me da lo mismo que tenía al principio. Así que esto está mal. This combination is wrong. So let me instead try. Let me change to a different color. Let me instead try 3k. And I'm going to put the 1. Let me put the 1 over here now and see if that makes a difference. Times k. And I'm going to put the 7 over here. Vamos a poner el 7 aquí atrás. Now let me multiply them and see if it makes a difference. 3k times k is 3k squared. 3k times 7 is 21k. 1 times k is k. And 1 times 7 is 7. Now it works. Because now, ahora sí trabaja. When I add that, I'm going to get 3k squared plus 22k plus 7. Alright, so now that is my answer. Esa es mi respuesta. Alright, so notice I had to do trial and error. My first combination did not work. That was not correct. I had to switch around the numbers to see which combination gives you that answer. All right, let me do one more and then I'll move on. All right, déjame hacer esta. All right, so at the beginning, I'm going to put 4f times f because that's the only thing you could break it up into, okay? Now, for 6, I could either do 1 times 6 or 2 times 3 or 3 times 2 or 6 times 1. Let me just try something. Let me try 3 times 2. Hopefully this won't take too long, okay? Para el 6, puedo tratar 1 por 6 o 6 por 1 o 3 por 2 o 2 por 3. All right, let me see if this works. Déjame ver si esto trabaja. When I multiply, I get 4f squared plus 8f plus 3f. Oh, wow. It actually worked first time. All right, I got lucky there. Trabajó la primera vez. All right, so 4f squared. I honestly did not have that one memorized. I just took a guess and hoped for the best. All right, so yeah, that gives me my original expression, so this is the answer. If it wouldn't have worked out, I would have tried switching the 3 into 2 and seeing if that works, right? All right, so there are some problems that you could practice with the answers there. I put the answers, so the answers are right. All right, okay, now, wow, after all this time, now we're looking at questions that are on the EOC or similar questions to what's on the EOC. Okay, aquí tenemos preguntas similar a lo que está en el EOC. So, which of the following expressions can be rewritten as a difference of squares? Select all that apply. ¿Cuál de las siguientes expresiones se puede escribir como una diferencia de cuadrados perfecto? All right, so there are the answers. Okay, now let me point out a couple things, all right? Let me point out a couple mistakes that you might make. All right, rewritten as a difference. Okay, the difference of squares means you got to be subtracting. That's important because that eliminates the answers where you're adding. Because the first thing I saw is that I thought, whoa, isn't that one maybe a difference of perfect squares? But you're not subtracting. That one has perfect squares because this, like, if I separate it into perfect squares, it would be that. But the issue is, this only works when you're subtracting. The difference of squares, you got to be subtracting, and this one's adding. So that's why this is wrong. Okay, en esta respuesta están sumando y por eso es que no es una diferencia de cuadrados perfectos. Tiene que estar restando. Porque este término y este término, los dos son cuadrados perfectos. Pero como no están restando, esto no trabaja. Así que esa no es una respuesta correcta. Hold on, let me check one more thing here. I got to double check things because the review I got this from I've already found several mistakes. Hold on, let me think about something real quick. Pause 1 second. Guys, this last answer, I'm going with that's a mistake, all right? Because I don't see how that's a perfect square. So this last answer is wrong. Ignore this. Esta respuesta está mal. All right, but the other ones are the difference of squares. Okay, so which expression is the simplified form? Okay, on this one, you got to distribute that 2 to everything, on the top and on the bottom. So you'd have 6 squared, x to the negative 8th power, y to the 6th power, over 2 to the 2nd power, x to the negative 2nd power, y to the 6th power. Okay, now you could do it in a couple steps. First of all, y to the 6th power over y to the 6th power cancels out, right? Let's get rid of the negative exponents by putting x to the negative 2nd power on the top and x to the negative 8th power on the bottom. All right, 6 to the 2nd power and 2 to the 2nd power. All right, now 6 to the 2nd power is 36, 2 to the 2nd power is 4, and x to the 2nd power over x to the 8th power. When you subtract the exponents, you're going to get x to the negative 6th power, which is that. You're going to have an x to the 6th power on the bottom. Okay, now 36 divided by 4 is 9. So your final answer would be 9 over x to the 6th power, which is this answer right here. All right, here you're just going to have to distribute to everything in here and then combine like terms. Tienen que distribuir y combinar los términos iguales.